So last time we started this chart, it just said F and F prime. We're going to add on to it today with F prime prime. So we had increasing and then what? Well, next to it though. Positive, good. Above sea level. And then decreasing negative. Now here's what we're going to add on. Well, a little bit of what we're going to add on. There's a couple of things. If that is true from here to here, then that is also true from here to here. And in theory, as many derivatives as you want to do. We're not going to go past the second derivative, but you understand what I'm saying? Okay, so you can copy this information over in these two columns, increasing positive, decreasing negative. And there's one more thing we're going to add on to that, but I have to explain some other stuff first. So last time, when we did first derivative equals 0, what was our vocabulary word for that? What were we finding? Critical points. Now, when you do second derivative equals 0, we call those inflection points. They get a different name because it's a different thing, okay? So first derivative is critical points, second derivative is inflection points. Here is the difference, the subtle thing though. When you set the first derivative equal to 0, those are critical points no matter what, period, end of story, they count. Do you remember how sometimes you don't get a maximum or minimum out of them, but they still count, they're still critical points. An inflection point is only an inflection point if you do get a change. Now, this is where f of x changes what's called concavity. And I always get somebody that's like teeth. No, it's not cavities like teeth. Have you ever heard of concave and convex? Or like a contact lens, do you know what I'm saying? It's how the graph bends. I call it a smiley face or a frowny face, but you have concave up and you have concave down. It only counts if there's a change. So you have to check that there's actually a change. If you don't want to draw these, that's fine. If you want to just look, or if you want to draw them with me, I'm just going to like margin problem up here above name. I'm going to draw you some pictures because they do this on the AP exam. If you are given the graph of f of x, you know how I coached you to be like, what did they give me? What do they want? All right. What did they give me? If they give you f of x, here's what a change in concavity would look like. This is concave up. This would be your inflection point. And then this is concave down. Do you see the change there? Sine and cosine are graphs that have a lot of inflection points. They go concave up, concave down, concave up, concave down. You're following me? Okay. So if you have f of x, it would look like this. So that would be like, yes, that counts as an inflection point. If you have something that's concave up and it switches to something linear, that doesn't count. It's not good enough. It's not a change from up to down or down to up. A line, something linear, has no concavity. There is no bend to it. So that doesn't count. And they are tricky like that. They will put things on there and be like, oh, it doesn't count. All right. So that's if you're given f of x. If you're given f prime of x, the change in concavity will happen with a change from increasing to decreasing or vice versa. So if you have something like this would be the inflection point. That would be, yes, that counts as an inflection point. But if you have something that's increasing and then it changes to constant, that doesn't count. And one year, this was several years ago at this point, they put a whole bunch of constant sections in the graph. Like they had it increase constant, decrease constant, increase constant. And then they asked how many inflection points are there? None of them counted. And I was like, oh, I bet all my students missed that because I didn't hit that hard enough. So now every single year I try to like be really specific. Like those don't count. There has to be a change. Okay. So what we're going to add on here, where your second derivative is positive, your graph is concave up, and that's an acceptable abbreviation for that. Negative means concave down. And this right here, I'm about ready to hand you all a sticky note, and I just want you to leave it stuck to your Chromebook. And I'm saying this on the recording because I say this all the time. I call these the sticky note problems. So when we get to the end of the year, every year on the free response part, there's always a sticky note problem. And I'm like, you just write out this chart and you look at it to get your answers. All right, so everybody take a minute, and I'm having this on the recording too. And I'm making myself a sticky note as well, so that I can pull this out. And I just leave it stuck here to my desk so that I always have it. So increasing positive, decreasing negative, and then if it's true from here to here, it's true from here to here. So you just kind of copy it over. And then second derivative being positive means concave up, negative means concave down. So it's all pretty intuitive, positive up, negative down. It's not like concave up, and then this is concave down. You can also write CU or CD. You tend to do things the way it got taught to you. That's how it got taught to me, so that's how I write it. And that is another way you can remember it because U is concave up, well spotted. All right. There's a lot of things in math that are intuitive that work out that way, so it's good. So yeah, you're gonna have that in a place where you can always grab it in case you need it. So if you have a critical point and your second derivative is, what does this mean? Positive or negative? Positive. That means your graph would be concave up. It would be like this. That means, does your critical point location of a relative maximum or relative minimum? Minimum, do you see that? If your graph is concave up, when you have a critical point, that's going to be the location of a relative minimum. If your second derivative is, what does this mean? Negative, that means concave down. It would look like this. If you have a critical point, that means your critical point is the location of a relative maximum. Good. And if your second derivative equals 0, then there's no conclusion. Basically, the test fails is what they say. Our second derivative test failed. You don't get a conclusion out of that, so you cannot conclude anything. So we're going to go through the entire process. This is going to be a review of last time as well. Find the critical values. How on earth do we do that? Yeah, take the derivative, set it equal to 0. All right, so our derivative is 3x squared plus 6x minus 9. We're going to set it equal to 0. Those will all divide by 3. I don't want to bore you to tears with the algebra. Is this okay, everybody? If I just kind of write this, we're all right. So what are your critical values? X equals 1, -3. Now, I didn't even draw a number line yet, but those are critical points. They count. Even if we do not get maximums or minimums out of them, they still count. Okay? The inflection points are a little different, so that's why I try to keep bringing that up. All right, intervals of increasing and decreasing. We're going to do exactly what we did last time. We're going to make a number line for our x minus 1, number line for our x plus 3. We factored a 3 out of that. You can make a number line for the 3 if you want, but 3 is positive all the time. You just have plus, 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 plus the whole way across, so you don't have to. -3 comes before +1. So just, be careful. Make sure you're going to be upset if you write them backwards on your quiz and I have to take off for that. Like that, you'll be upset. So just be careful. And then how can I fill these in since nothing is backwards or weird or squared or negative? Yeah, negative to positive. I'm going to draw your little balloon strings. And so what's your overall sign for the first section? Yeah, positive and then negative, positive. Now, I didn't say justify on here, so we're going to just do that part verbally. Remember all the writing I made you do last time? I'm going to let you off the hook. We're going to just do it verbally as long as you stay with me. How does the sentence start? F of x is or f of x has? Okay, so we're going to say f of x is increasing where? -infinity, -3. Okay, now I'm not going to make you write the justification, but let's just say it. It would be because, who's your source that you cite? F prime is positive there, say there, or on that interval, all right? Because F prime is positive there. All right, and then the sibling statement, don't say sibling statement outside of this room. That's a Miss Cole-ism. That's like another one of my things that I say that's not like accepted vocabulary, outside of here. F of x is decreasing everywhere else for the opposite reason. So you'd say -3 to 1 because F prime is negative there. Good. f of x has a relative maximum at x equals which one? Let's stop and think about it. It's either the -3 or the +1. Maximum at which one of them? At the -3, and again, we're going to do the justification verbally. At -3 because, you can't say it, they will not give that to you. I know it sounds like I'm so hateful. Because f prime changes from positive to negative there. Because f prime, that's your source, changes from positive to negative there. And then your sibling statement, f of x has a relative minimum at x equals 1 because y. If you say it, they will not give it to you. F prime changes from negative to positive. You can be mad at me if you want. I will coach you through this so that you will get it correct on your AP exam. I know it sounds like I'm being super hateful. I just want you to get all your points, okay? You can be upset. I just want you to have the right answer. You can't say it. Because who? F prime changes from negative to positive there. It's not, the sentences are the exact same ones I made you write last time. They're not any different. That's the answer. I can't change that because it's a definition thing. All right, absolute extrema. Does anyone remember what this test is called that we're about to do here? All right, yeah, this is your candidates test. Now, who are your candidates? Endpoints, which is -4 and 0. And your, what do we call these? Critical points. Endpoints and critical points. Are they both on the interval? Yes, they are. Oh, no, wait, one isn't. Yeah, okay, cool. I was going to say, it's nice sometimes when one of them's not, because then you don't have to do that one, and it's less work, and that makes us all happy. Now, where do those get plugged into? I wrote it on the paper, but I'm just checking that you're... Where do they get plugged into? The OG function. Good, the OG function. The original one. The one all the way back up here. All right? We're going to fight through this. Sometimes you have to do it without a calculator. If you plug in -4, what is -4 cubed? -64. -4 squared is 16 times 3, 48. -4 times -9, +36, and then +4. Usually what I'll do is group together all the positive numbers and then all the negative numbers. 36 and 4 is 40, plus 48 would be 88, minus 64, so 24. Good, we battled through it. Good. You need to be able to do that. It's a skill that you're going to have to be able to get through. All right, now -3. -3 cubed. -27. Thank you. Are we all together here? -3 squared is 9 times 3 is 27, which is convenient. -3 times -9 is 27. Plus 4. All right, so these two cancel. 31. And then you catch a break with 0. If you plug in 0, what are you going to get? 4. Good. Hey. Are you okay?
Yeah, we're doing it.
All right. The absolute maximum is, what is the biggest number you got? 31 at x equals -3. And your absolute minimum is, what is the lowest number you got? 4 at x equals 0. I coach everybody to write it that way every time. Sometimes they ask you for the maximum and minimum. That'd be 31 and 4. Sometimes they ask you for the location. That would be the -3 and 0. But if you write it this way, you will get it correct every single time, no matter how they word it. So just write it that way. Yes. Yes. The only one I think they won't take is don't put a plus sign for positive and like a minus sign for negative. Actually, like write POS period for positive. Now, it doesn't say to justify, but if you did need to justify, you don't have to write anything else because do you remember how this works? The chart is your justification, so you don't have to say anything else. All right. That was all review from last time. Now we're going to venture forward into what I just taught you at the top of this paper. Find the inflection points. This is second derivative. So look back at your first derivative, which is back here in part A, this 3x squared plus 6x minus 9. What is your second derivative going to be? Good. And we're going to set that equal to 0. So I'm getting -1. Now, critical points are critical points no matter what. They count. That is only an inflection point if there's a change. So I'm going to go ahead and make my number line for my 6x plus 6. And did anything weird happen? Is anything backwards? Do you see an extra negative out front? Is anything squared? No. So it's going to be negative and then turn positive. So this does count because there's a change. Okay? Only counts if there's a change. Correct. I was wondering if somebody would come with a gold star for you. The only time there's really not going to be a change is if you end up with something squared, because that would be plus, 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 plus the whole way across. Okay. Your sentences are going to start the same way. F of x is or F of x has. All right. So F of x is concave up. Where do you think? Look at our number line that we drew. -1 to infinity. I didn't have a justify here, but we're going to write it because this is the new stuff. So because, who's your source this time? Because it's not f prime. Second derivative. Good job. Because f prime prime is what? Positive there. You have to say there or on that interval. And then your sibling statement, f of x is concave down everywhere else for the opposite reason. And I think I'm going to do like one more before I give us our halfway break. And again, we're not going to do every single thing on this paper. I'm kind of picking and choosing. Because this is a lot. I should have deleted some things. We're going to do number 3. And then we'll do our halfway. Well, with a whole bunch of parts to it. But they do that on the AP exam. We'll have like parts A, B, C, and D. We're going to skip number 2. We don't need to do every single thing on here. All right, so we're going to do number 3. F of x is a continuous function on 0 to 3. Given all of this information, that's a lot to sift through. So I'm going to just go ahead and read the question and we'll see what happens. All right. Actually, you know what? I'm going to do the graph first. I think it'll be easier if we do the graph first and then we can use it to answer all of this. So I'm going to ignore this for a second. Let's go ahead and graph this. So do you see how we have x values and then we have f of x values? This should say f of x. So we can plot all these points. Your first point is 0, 0. So I can go ahead and put that on my grid. What's the next point we can go ahead and plot? Yeah, 1, -2. You see that there? 1, -2. I'm going to have to zoom out a little bit so I can see the whole thing at once. All right, and then what's the next one? 2, 0. And then 3, 3. Now, you don't really need to look at the first derivative, and this is why. First derivative tells you increasing and decreasing. Hey, kiddos, can I get from here to here without decreasing? Or from here to here without increasing? That's just going to happen. It's built in. So you don't need to look at first derivative. You really just need second derivative. It tells you your smiley face or your frowny face, your concave up or concave down. So on this interval from 0 to 1, second derivative, do you see where I'm pointing there? Positive. That means concave up like a smiley face. So from 0 to 1, you want to be concave up. Do you see how I'm bending it? Like, this is always hard for everybody because it's one of those things where I can't shake you and be like, do you see it? But one year, what we came up with that helped everybody was if you imagine water dripping into here, it would catch it. Do you see what I'm saying? And if it was concave down, if you imagine water dripping onto it, it would roll off like an umbrella. Like, does that help at all? I mean, like, I don't know, that's what we came up with one year and it helped everybody. So that's what we...
That would like fun.
Well, well, it would look like this. All right. Next interval, like a umbrella, the water would drip off of it. All right, next interval from 1 to 2, our second derivative is positive. So concave up. So from here to here, when you connect them, you still want to be concave up. And then from 2 to 3, it is still concave up. So it's going to look like this. Do you see how there's a cusp there? What's in the table reinforces that that's a cusp there. Perfect. All right. Now let's just use that picture to answer all the questions. Absolute maximum. What is the highest point that you see? Yeah, but we write it 3 at x equals 3. You just kind of switch it around. Absolute minimum, the lowest point you see there. Yep, -2 at x equals 1. Now relative. Those can't be endpoints because they are not relative to anything on the other side. So it has to be somewhere within the interval. So that means for a maximum, it has to go up and come back down. For a minimum, it has to go down and come back up. So we don't have one of these, and that's okay. Just, yeah, I haven't got one. Now we do have a relative minimum. It is, yeah, and they can be the same. That's okay. -2 at x equals 1. And then this is the new thing, inflection points. You have to have a change in concavity. Well, this is concave up, and concave up, so none. Good, I usually get people to overthink that, but you all jumped right on board. None, we like the answer none, it's good. All right, so we're gonna draw our own graph with the following characteristics. So vertical asymptote x equals 1. We're gonna go ahead and dot that in. Horizontal asymptote y equals 2. I'm going to go ahead and dot that the whole way through. But if you were with me for pre-calc, do you remember me saying usually just dot them at the edges because something weird could happen in the middle? But we're in charge of this graph and I'm not going to do anything weird. So I'm going to just dot it the whole way across. Now I know this kind of got like all blended together, but it says f prime. Oh, do you have your little sticky note? Yeah. It says f prime is what? What does this mean? Negative. Negative. Look at your sticky note in the f prime column. If f prime is negative, what does that mean your function is doing? See how easy that is when you just pull out your sticky note? Well, you're going to write it when you get your exam, all right? So we want to be, now hold on, we want to be decreasing on this side. So I can either draw my graph up here or down here. So if I want to be decreasing, it's going to have to go like this because you have to like coast along the asymptotes. And then what does this mean? F prime is positive. Look at your sticky note. If f prime is positive, that means the graph should be increasing. We want to be increasing on this side. So will I draw my graph above or below that horizontal? Well, concavity didn't come into it. We want it to be decreasing and then increasing. So this side is decreasing, this side is increasing. Number 5 is a repeat of number 1 where you just go through that whole process, and we're about to do that again on the quiz review, so I'm not going to make you do that one. We're going to do 6 and then we'll do a couple on the back. So number 6. I actually really like this question. It's not hard and there's really no work, but you have to like know your stuff, okay? F of 3 equals 7. All that means is the point 3, 7 exists on the graph. That's all that means. I always write everything as an ordered pair. Now, I'm not going to tell you the rest of this. I'm going to pull it out of you, all right? If your derivative at 3 is 0, if your derivative equals 3, what does that mean? It's a what? It's a critical point. Slope equals 0 is what that means, but critical point is what I was looking for. It's a critical point. Now, this is where people get tripped up. It's prime, so second derivative is -4. It doesn't matter that it's -4. It could be -17,000. The point is that it is negative. So don't get caught up on the 4. If your second derivative is negative, what does that mean your graph is doing? Concave down. Negative means concave down. So that means your graph looks like this. I just always draw that. You don't have to. If you have an imagination, you can just envision it. But your critical point would be this one. So what does that mean that critical point is the location of? Relative maximum is the answer. I like that because did we really do any math? No, but you had to know a whole lot of vocabulary and be able to envision that to answer the question. So I actually really like that question. We'll just do a few of these. Now, the grid kind of ran into what that says there. This is f prime. So what you have the graph of is your first derivative. That is 90% of the time how they do this. They give you the first derivative. Are they going to ask you questions about the first derivative? No, they're going to ask you questions about f of x. So you have to understand that you are answering questions about not this graph. You are answering questions about not the graph you are looking at. Do you understand? This is just your source. This is like the guy you're interviewing about somebody else. No, we're going to use the graph, but we're going to also use our sticky note. Okay. So on what intervals is the function f of x, not the one you're looking at, increasing? Look at your sticky note. F of x increasing means first derivative is, that means above sea level. Where is this graph that you're looking at above sea level? Oh, you know what? Actually, I don't think it's negative infinity as I write that. I think we have an interval. Yeah, -8 to 10. Okay, so increasing would be -8 to -6. You guys were correct. Union, -2. Now you can actually keep going past 4 because we're still above sea level all the way until, yeah, we'll say that 9 is 9.5. So where is f of x, not the graph you're looking at, decreasing? -6 to -2. 9.5 to 10. It ends at 10. Cool. Concave upwards. Look at your sticky note where f of x, the first column, is concave up. What is f prime, the middle column, doing? Good. Where is the graph you are looking at increasing? -4 to 2. Good. Union. 4 to 7. Good. Concave down would be where f prime is doing what? Decreasing. That's going to be -8 to -4. Union, what else? 2 to 4. Union, 7 to 10. They wrote local in this. That means relative. Okay. X coordinates of relative or local maximums. That is where your first derivative changes from what to what. This is from last time. Maximum is a change from, that's above to below, positive to negative. Where does this graph change from above to below? There's 2 of them. -6, 9.5. Good. Local minimum, that's a change in first derivative from negative to positive. That's below to above. So where do we have a change below to above? -2. I'm going to do a follow-up question that's not on here. What's your other critical point that didn't give you a maximum or minimum? Say that louder. 4. 4 is still a critical point. We just don't get a maximum or minimum out of it, but it still counts, right? And then the last one we're going to do for today, points of inflection. Look at your sticky note. That's a change in concavity, concave up to concave down. That is where f prime, look at your middle column, changes from what to what? Look at your sticky note. Increasing to decreasing or decreasing to, hold on, let me pull out my sticky note. Can you guys all look up here? Because that was a little shaky. Change in concavity is where the first derivative changes from increasing to decreasing or decreasing to increasing. I'm actually going to have us write out the justification on this one, and this is the reason why. It was another thing I found out afterwards. I was like, wow, I really wish I would have said that to my students. I asked at a seminar once, isn't there a shorter way to justify that? Like, can't you say changes direction? And they said, no, you must say changes from increasing to decreasing or from decreasing to increasing there. And I was like, okay, I mean, you can write it. It's annoying. You're allowed to be annoyed. Your feelings are valid. But that's what they told me you have to write to get credit. So let me show you how we justify that. F of x has, we're going to write our whole sentence here. F of x has inflection points at x equals, and there are a bunch of them. So where do you think? Where have we got one? -4, good. And this is what I was talking about. Does this count? No. This one does though, because we changed from, okay, good. So 2 counts. Where else? 4 is 1 and 7. Because f prime changes from increasing to decreasing or decreasing to increasing there. I am the messenger. I asked, isn't there a shorter way to say that? And they said, no, your students have to write it that way to get credit. If you are like, wait, that was inflection points. Why didn't we cite the second derivative? Why didn't we cite the second derivative? We didn't find the second derivative. You have to cite who you've got, and who have we got? First derivative. So you have to cite who you've got, okay? What are your conditions for mean value theorem? There are two of them. Continuous and differentiable. Since this is a polynomial, it's a cubic graph, it's going to just wiggle. There won't be any sharp edges. There aren't any asymptotes. There aren't any holes or gaps or anything. So we're going to say f of x is continuous on, what's our interval? Yeah, -2 to 0, and differentiable on the open interval. So that's how you would say that. So we can do the problem, but you have to remember what mean value theorem means. So it is your derivative equals your slope. So to get your slope, you need 2 points. We're going to plug in -2 and we're going to plug in 0. I'm going to do 0 first because it's easier. What do you get if you plug in 0? Yeah, 4. If you plug in -2, let's see. You with me here? -2 cubed. -8. That would be +8. +2. +4. So 6. Consensus there? Okay. So do your slope. It'll be 4 minus 6 over 0 plus 2. What is that going to shake out to be? -1. You're going to set that equal to what? The derivative, which what is your derivative of this thing? 3x squared plus 4x minus 1. Now you have to evacuate. So if you add over this 1, what's going to happen to them? Yeah, it's going to cancel out. And so you're not going to split it because it's not a trinomial anymore. What's the best that you can do? Like, what's the kind of factoring? Yeah, take out x, GCF. So you'd be left with 3x plus 4. And so this first one gives you 0, and then the other one gives you -4/3. Keep them both, get rid of them both, get rid of one or the other. That's an endpoint, so we're going to get rid of it. Is this one on the interval? Yes, so that is our answer. Good job. This is the hard one. You're going to plug in -1 and you're going to plug in 4. And even if you can't do anything else, I believe in my heart, you can do that part. All right. So if you plug in -1, what is that going to be? -2 minus 3 be -5 minus 7. Does anybody do it and get -12? It's okay. I'm a human. I make mistakes too. I'm just checking. All right. 4 cubed is 64. Double that is 128. Plus 12 minus 7. 133. I agree. I was counting my fingers. Hold on. Is this function continuous? Yes. All right. So since f of x is continuous on -1 to 4, and intermediate means between. So we're looking for 0 here. So we're going to say 0 is between, you can abbreviate between, f of -1 and, I ran out of space there. I usually like for that to all be on the same line because I'm like, first thing continuous, second thing in between, but I just ran out of space. After you do that, you mention continuous, you mention in between, then you do what? Restate the question. You would say, since all that is true, f of x has a 0 on -1 to 4. I just copied this. I didn't write the whole thing again. I just wrote f of x has a 0 on -1 to 4. And you have to say one more thing, which is exhausting. Oops. By intermediate value theorem. Polynomials are continuous. If you have an x squared or an x cubed or an x to the fifth or an x to the 17th, that's going to be continuous. The only graphs that aren't continuous are rational, asymptotes, and logarithmic. And piecewise sometimes if they don't link up. Everything else is continuous. Absolute value is continuous, but not differentiable, so you got to watch out for that one. But most of your parent functions are continuous. All right, and then this is the stuff we were doing today. We'll do this nice and quick. Critical points, how on earth do you do that? Derivative equals 0. So this will be 6x squared minus 24 equals 0. There's two ways you can do this. You can factor, or you can just straight up solve it, like add the 24, divide by 6. Is that your head's nodding? Okay, so we'll do that. If you add the 24, that's going to give you this. Divide by 6. And then what are your answers? Plural, because there is more than one. Yeah, plus and minus 2. If you wrote plus and minus 100% full credit, I like to write them separate though, so I remember that there's 2 of them, but for heaven's sake, that's fine. All right. Now here we need to make our number line. I didn't end up factoring this. That's okay. I can put it all together on the same number line. If you wanted to factor it, you would end up with an x plus 2 and an x minus 2. It'd be a difference of squares, but you can do it this way. You're at a place where like you can make a choice how you do the problem. As long as you end up with the right answer and justification, you're fine. This is going to alternate. So I'm just going to pick a number in the middle. The reason I'm going to choose that is there's a very easy number to choose here in the middle, which is what? 0. Good. Thank you for coming with me on that. If you plug in 0, you get negative 24. So this middle section is negative, and so I know the other 2 are positive. You could pick it more test numbers, but I promise you it's going to alternate. All right. So how do your sentences start? Because this says justify. We're going to have to write some sentences. F of x is good. And we're going to say increasing. Good. Union. 2 to positive infinity. Because who is your source that you're citing? F prime is positive there. And I'm going to write the sibling statement. I'm not going to say it verbally because that gets annoying. F of x is decreasing everywhere else for the opposite reason. Pausing to give everyone a chance to write it. But you can get good at just churning those out. And on the AP exam, that's your answer. On the test for me, that's your answer. I can't change these because statements because they're definitions. Like those are the, I'm giving you the test answers ahead of time is what's happening. All right, inflection points. This is the new thing today. So what do we need to find? Yeah. Double prime. So look back at f prime, 6x squared minus 24. What do you get? 12x. If you set that equal to 0, you're simply going to get 0. Now that only counts if there's a change, but there's going to be. If you make a number line for 12x, it's negative and turns positive. So that counts. These sentences for number 6 are going to be practically identical to the sentences from number 4. Just very slight change, all right? F of x is, instead of increasing or decreasing, I'm going to say, yeah, concave up, concave down, all right? F of x is concave up on what interval do you think? Look at the little number line that we drew. Yeah, 0 to infinity. Because, now this is where there's a difference. Who's your source now? F prime prime is positive there. And then your sibling sentence. You're like, this is annoying. I don't want to write this. You're going to be okay. You're practically just writing the same thing twice, almost. And again, I drill these because then when you get to the AP, they put this on free response every year. It will be on there. I don't know which part of it, but it will be. All right, local maximums and minimums. That means relative. We're going to look back at this number line. And our sentence is still going to start f of x is or f of x has. This one's going to be f of x has a relative maximum at x equals, which one do you think? Where is the maximum? -2 is where the maximum is. Because, who's your source? F prime does what at -2? Here, I'll point to it. What happens at -2? Perfect. F prime changes from positive to negative there. And then I'm going to write the sibling statement. Minimum is at x equals +2 because F prime changes from what to what? Negative to positive there. I call this the English unit sometimes. I call the last unit the physics unit because of all the velocity acceleration. Then I call this the English unit because your essay writing is what you're doing. It's not that bad. It's not as bad as stats, I don't think. You do a lot more writing in there. Yeah, oh yeah, you write pages and pages. This is not bad compared to that. But this is where we do most of our writing. All right, absolute. What test is that? We did hangman earlier. Candidates, good job. All right, who are your candidates? Endpoints. Wait, do we have an interval? Oh, it's at the very top. -3 and +3. Those are our endpoints. And then who else? And that's because those are our critical points. It's endpoints and critical points. For the sake of time, and because I've talked you through a lot of these today, I'm just going to glance at my answer key. If anybody did this ahead of me, you can tell me if I'm right or not. You would plug these into what? Yeah, the OG function, which is this one all the way back up here at the very beginning. I believe in my heart you could do that. This one's going to give you 18, 32, and then you have symmetry here. So -32, -18. Again, for the sake of time, and because I just believe you could do that, I'm going to go ahead and fill that in. The justification is the chart. You just have to write the answer. So absolute max is what? 32 at x equals -2. And then absolute minimum is -32 at x equals 2. Again, and you're like, she keeps saying the same thing over and over. That's because it's important, and I've seen this test a lot. Sometimes they ask for the maximum and minimum. That would be these numbers. Sometimes they ask for the location. That would be these numbers. If you write it this way, you will get it correct no matter how they word it. So just do that every time and you will be A-okay.